So for activity 3, we're going to look at how to create symbols for altered chromosome structures and aneuploidies that are detected by a cytogeneticist in a karyotyping analysis. And so we start with the symbol for a normal human male is 46, XY. That means that in the metaphase spread, the cytogeneticist counted the normal number of chromosomes, 46, including one X and one Y. For a female, it would be 46, XX. So that's the normal symbol for normal male and normal female. For aneuploidy, an aneuploidy means that there's an extra chromosome or a missing chromosome altogether. So that would be a chromosome number per cell of 47 for a trisomy, 3 copies of one of the chromosome types, or a monosomy of one type of chromosome, which would give you a diploid number of 45 chromosomes per cell. And then in that case, you indicate after the diploid number of 47 or 45, you indicate the sex chromosome makeup. In some cases, then you're done with the symbol if the aneuploidy is one that involves the sex chromosomes. Or if it's an aneuploidy of the autosomes, then after the sex chromosome makeup, you indicate which chromosome is extra. And with a plus 21, plus 18, plus 13, for example. So we're going to go through these, and these are the types that are viable. Any aneuploidy can be conceived at the moment of fertilization and have been recovered in naturally aborted fetus samples. But the only ones that can survive live birth are the ones listed here. So the viable aneuploidies are mostly named after some physician that first described them. So you have Turner syndrome. That's a female with a monosomy X. Symbol is 45, X. So one whole chromosome X is missing, but the phenotype is female. Now that's an aneuploidy and specifically a monosomy. We do not call this a deletion of X. Deletion is a different term, a specific term that only can be used to describe abnormal chromosome structures, which we'll go over below. Then you see that Klinefelter's is phenotypically male, so we say male with an extra X chromosome. So the symbol is 47, XXY. That's the most common version. Triplo X is a female with 3 X's, 47, XXX. Double Y is a male with 2 Y's, so 47, XYY. Those are all the aneuploidies of the sex chromosomes. Those tend to be more viable or more likely to be viable, although there are aborted fetuses that have these kinds of sex chromosomal abnormalities. In terms of autosomal aneuploidies, we have Down syndrome. That can be male or female because it involves the extra copy of chromosome 21, which is an autosome. So the symbol would be 47, XX or XY, plus 21. That means there's an extra copy of 21. This is not called a duplication of 21. That term duplication means something different. So you have a monosomy if there's only one copy of a certain chromosome. You have a trisomy if there's 3 copies of a certain chromosome. But all the other chromosomes are implied to be in their normal diploid number, which is 2 copies each. Edwards syndrome is a trisomy of chromosome 18, and Patau syndrome is a trisomy of chromosome 13. These are viable, but tend to die in the first year of life. So Down syndrome is the only trisomy that reliably, fairly, pretty much all the time, survives to about age 50. So you'll study that in lecture a little bit more. Okay, so if we skip below, we're going to look at the structurally altered chromosomes. And these are shown about halfway down the page. So if the cytogeneticist looks at a metaphase spread and determines that there are 46 chromosomes, but one of the 46 has some kind of structural abnormality, then we use this symbol that I've shown you some examples down here in this part of the document. So 46, XY, that would be a male with 46 chromosomes, but one of the chromosomes has a deletion. We use after the XY comma, we say DEL, and then which chromosome number is affected, 4, if that was the case. And then in the next set of parentheses, we see the actual place where the deletion exists or where the chromosome has broken off. So in this case, P16.3. So you would be told that information and then you would formulate the symbol. If there is a deletion that involves 2 breakpoints and the piece in between is gone, that's a deletion as well. And you would indicate the 2 breakpoints in that set of parentheses after which chromosome is affected. There are 2 kinds of inversions. An inversion means the chromosome broke in 2 places and the piece in between the breaks flipped and rejoined. So nothing's missing. It's just part of the chromosome is inverted in contrast to what the normal arrangement is. And so a paracentric inversion, that means that both the breakpoints are next to but not including the centromere. So both of the breakpoints on the P arm or both of the breakpoints on the Q arm would mean that the centromere is not included in the inverted piece. The other option is a P-E-R-I, pericentric inversion, which means 1 breakpoint's on the P arm, 1 breakpoint's on the Q arm, and the centromere is included in the inverted piece. It's just a descriptive term. A duplication, that's where you have 46 chromosomes, but within one of the chromosomes, there's a section that's been duplicated. It usually occurs in tandem, the same section twice. So that's a duplication. So one chromosome is longer than its homologous partner. So in this example, duplication on chromosome 1, bounded by the band Q22 to Q25. And that section is repeated twice on one copy of chromosome 1. And a translocation is an exchange between 2 non-homologous chromosomes. And I'm giving you just kind of a simple translocation. It's called a reciprocal translocation. These can get very complex, but I'm giving you kind of a simple example just to start off with. It's a translocation T between one copy of chromosome 2 and one copy of chromosome 6, where the breakpoint on chromosome 2 was at Q35 and the breakpoint on chromosome 6 was at P21.3. So those are just examples, like models, that you're going to follow that sort of layout. So down here at the bottom, I have 7 questions. Well, 7 statements, 7 descriptions of what a cytogeneticist might see on a karyotype, and you're going to convert those descriptions into this format, into this symbol format. If it's an aneuploidy, a monosomy, or a trisomy, you'll model it after what we have up top. If it is a structural abnormality, a deletion, a duplication, an inversion, or a translocation, you'll model it after these examples right here in the middle. So what I would suggest is that you try to fill these in and then compare it to the answer key that I've posted. And that way you'll be prepared. There will be something on the quiz, the grade for this online lab, that you'll be very similar to these, and you'll have to type in the symbol.